Okay, live stream's up. Doesn't look like there's anyone on at the moment, so I'm just gonna wait for people to show up on this. Should be 8 of you, I would have thought, for this. So what are we looking at? We're looking at 11G on page 312. So it's exercise 11G on page 312, and that's what we're working on today. Okay, so if you are here, can you pop your name in the chat box? I know I've got to register online. I haven't had a chance to upload it onto the college system because it's incredibly hard to get onto. But I have recorded all your registers, so when the time comes, I'll be able to fill in all of them. So you don't need to worry about registers, Kai-san. I think it was Kai-san that asked. As soon as I'm able to get on them, I'll update them all. So can everyone who's in there, Xing's in there, excellent. So yeah, sign in here, also sign in on Microsoft Teams as well, all right? So that way I've got you covered both ways. So if there's any issue about attendance, we've got the evidence online, so don't delete these. So it seems like we've got 2 people now, so someone's dropped off. The questions we're doing are from exercise 11G on page 312 of the Pure book. It's the Pure second year book. So either use the PDF copy, yeah? Either use the PDF copy or use the pack that I gave you many, many moons ago, okay? So if I can only see Xing in the chat box, I need to see all your names in the chat box, please. And we'll start when that's happened. So we've got 4 people online. Can everyone sign into the chat box, please, so I can see that you're all there. So we've got Kai-san, brilliant, Xing there, well done. So the format of these double lessons are going to work as follows, right? So what I'm going to do is I'm going to do 2 live streams. I'll do one now, and then I'll do one at about 11 o'clock. And so one will be done on, well, this one's integration from using partial fractions, and the other one will be on statistics. We'll finish off this stuff about binomial distribution and hypothesis testing. So you'll have 2 live streams today, each one about half an hour's length. It might be a little bit shorter if I can get the ideas across. And then what you do is you finish off the exercise. What exercise am I talking about? Exercise 11G, page 312, Pure 2. Okay? And what I'm going to do is take you through the examples. Brilliant. We've got 5 of you here. Take you through, there's one person who hasn't signed in yet. Take you through these examples that we're doing here, these questions that we're doing. And then, good morning, Kelvin. And once I feel like you've understood it, I'll let you go away and do those examples. I will be again live streaming at 11 o'clock for the second lesson. All right? Yes, Kelvin. I know it's Kelvin because you said good morning as Kelvin Law. I don't think you're role playing someone else. Okay, cool. So let's roll. And I'm going to start by doing the very, very first exercise in 11G. So if you haven't got your textbook ready, try and acquire it in the next few seconds. Also, I'll write out the question this time, but have your textbooks with you at all times, all right? So for next lesson, the textbook you're going to need is the stats first year textbook, all right? But for this lesson, looks like everyone's in now. That's brilliant. Everybody brilliant. I guess just let's start then, shall we? And let's use, says use partial fractions to integrate the following. So we're going to start. So just make it, I'm going to hold that there just for one more second. It's exercise 11G, page 315 from the Pure 2 textbook. For the live stream, I'm going to do at 11 o'clock for you guys. It will be the first year textbook, statistics chapter, and so basically applied chapter 7. All right, let's roll. So the question that you're asked is use partial fractions to integrate the following. So you're integrating. Can someone email him the book? Because I'm in the middle of a stream right now. I've emailed the book so many times at this point. It's so frustrating. Okay, this is what you need to do. Once you've got a spare minute today, go through all the emails I've sent you, make a folder on your computer or your laptop or your tablet or whatever, thank you, man, with everything I've ever sent you. And that way you never need to ask me this stuff because like this is so crucial for our lessons, all right? X plus 1, X plus 2, all right? And if I start emailing you the textbook every single time, it will clog up your emails very, very quickly. Because these are like 20 megabytes each time or something like that. Okay, we're all good? So Iman's sending him the textbooks, that's fine. And what we're doing, you can't actually see that, so I'm going to just move the camera a little bit better so you can. There we go. Okay. That's the integral we're doing. And the way we're going to do it is partial fractions. So you can't really integrate this nicely, but what you can do is write it in the form of a over x plus 1 and b over x plus 2. And I'm going to ask you, as your first task of today, can you tell me what A and B are? Okay, so once you've got values for A and B, Can you put them in the chat box for me? I'm going to give you about 4 minutes to do that. So that's a revision of stuff that we've already covered. It's not one of those horrible ones which got repeated roots. It's just a simple partial fractions question. Let me know as soon as you've done it. Okay, in fact, you'd have to let me know. You've got to pop the answer in the chat box. Even if you haven't got the textbook for right this minute, the question's on the plastic. Can't really call it a whiteboard because it's not hard. Sorry, do you need a drink there? So yeah, you're in. All I'm asking you to do is find a and b, and it's a over x plus 1 plus b over x plus 2. I want you to find a and b for me, no further. Just to keep reiterating how we're going to run this today, there will be another live stream at about 11 o'clock. So you've got 9 people. Who's the 9th person, just out of curiosity? If you are year 13 sneakily watching this, or even a year 12, it is useful to you. Definitely for year 13, it's a nice bit of revision of integration with partial fractions. Drop down to 8 people again. So yeah, so this is literally integration with partial fractions, and that's all it is. As soon as you found out a and b, can you pop it in the chat box? If you can't do it, can you pop that in the chat box as well? Because that's super useful if you don't know how to do this. A is 2, B is 1. Do we agree? Do I want you to integrate it? Not yet. I wanted to show that. I suspect you probably already know because we sort of covered it right at the end, didn't we? I'm going to go with Shiying's numbers and go, well, that's the same as saying integrate 2x plus 1 plus 1x plus 2. The reason why I can say that is because this is that fundamentally. I hope that makes sense to people. And assuming that Shiying's got the numbers right, there's no reason for me to believe that she hasn't as it stands. And if, please someone correct it if she hasn't. How do we deal with that? It's what we do is we make it in the form f dashed of x over f of x, which is a familiar form to us because we know that is ln f of x plus c. Yeah? I mean, that's just gone off on the side, but you know what it is, right? You've seen that before. Someone's got a is minus 3. Can we have a little debate on this then? I mean, I'll do it if I have to. What are we saying, guys? Eman, Rebut, what numbers are you coming up with? Because I've got Shiying claiming a is 2, and we've got Kaisenik claiming that a is minus 3. B is 11. I mean, do I need to do this? Let's just do it quickly. So you've got ax plus 2 plus bx plus 1 equals 3x plus 5. Yeah? So it follows that a plus b equals 3 and 2a plus b equals 5. I'm with Shiying. Yeah, absolutely. I've no clue where you got minus 3 and 11 from. Minus 3 plus 11 wouldn't give you... Yeah, you definitely did. Look at my working out a couple of lines I've put there. I'm even going to just put it down a bit so you can see all of it. Yeah, there we go. So what I've said is you just cross multiply. Yeah. I'm with Shiying is right. Kai-san, you might want to have a look at what you did wrong and then tell us what you did wrong. So, oh, okay. So it's just a miscopy. That's fair enough then. Right, let's move on. So what do we do here? This is almost in the right form. The other one is. So we can go straight, that's just ln x plus 2 plus c, obviously. B's 1, boss. B's 1. A is 2, B is 1. This is almost right. So what we do is we go, well, this is 2 on the outside, 1 over x plus 1, because we're allowed to do that with integrals. So then we've now got 2 ln x plus 1 here. All right? So we've got 2 ln x plus 1 in the modulus plus ln x plus 2 plus c. Can we tidy that up? Yeah, sure we can. So we've got ln modulus x plus 1 squared x plus 2 plus c. Yeah, because laws of logs. And that's a very, very simple integral, right? I hope that's not too bad for people. That seems reasonably sensible, right? Okay. There are, of course, harder ones. Let's see what we can find. Let's have a look at 2b. 2b is a shell. Yeah, 2b is a shell. I'm going to leave that just there for a second, but we're going to do 2b in just a moment. So if you want to kind of flick ahead, look at page 312, exercise 11G 2b. That's the one where we're going to be going to next. So I'm going to pivot to that in about 30 seconds. I think everyone's sort of in the right place with this, hopefully. If you don't understand, can you pop a message in the box? I'll give that about another 10 seconds before I kind of move on to, and the question I'm going to move on to is 2b, exercise 11G, page 312. So the same thing again. Seem to have lost someone. Okay, cool. Let's do this. Let's do this for a second. Clear all of this off. Okay, this one is considerably more complicated, not much harder. What does it say on the right? I don't know, I just rubbed it off. Does anyone want to just pop up and give him back the solution? It's kind of, so we've got x cubed. You can see this, you can see that. Can you see that? Just about? No. Thank you. Yeah. And this one's a much challenging, much more, it wasn't massively difficult, but you know, it's more challenging than the last one. So we've got x cubed, 2x squared plus 2. And you've got x plus 1. dx. And that doesn't look much like the previous one at all, really. It's, you've got a cubic over a quadratic, and there's no kind of, there's a fraction going on, but like it's a top-heavy fraction. So we need to do something here, yeah? Yes, there's something to do with MOX. So I'm just going to deal with that. So we can see there's a difference here. And how we deal with this is by doing algebraic long division. Do you remember this guy? And when it's just expand the bracket, that's just, this is just the denominator. Can I ask you to do this division for me? And then I'm going to do this division and we'll mark it together. All right? So when you've got a question like this, the first step is to do a bit of algebraic long division. I'm going to move the camera in your favor this way. There we go. So whenever you've got a question like this where you've got a top-heavy fraction to integrate, this is your first move. Divide the numerator by the denominator. So what you need to be doing is doing the algebraic long division. Can you post in the chat box if you don't know how to do algebraic long division? please post in the chat box if you do not know how to do algebraic long division, or you've forgotten, or you struggle with it. In any case, first thing I'd do is replace the +2 with a 0x plus 2. How would what work? The thing with chat boxes, you need to kind of explain in exact detail what the hell you don't understand, all right? Because I can't see your face. You're a bit stuck. Okay, cool. Let's just do it together then. So how would that work? You're going to end up with a number. Let's do it because clearly there's a problem there. X cubed dividing into x squared is just x. Yeah? Does that make sense? Well, let's just do that. Let's see what happens. Times both of those by x. You get x cubed plus x squared. Yeah? Watch. You may as well just watch at this point because I'm literally going through the damn thing. I wish people would stop emailing me mid-thing. Is everyone happy with the first line? Yes or no? So can you post in the chat box if you understand what I did in the first line? We'll get on to that, yeah? I'm not going to rush it. We'll see what happens, right? We're happy so far. Yeah, happy so far. Good, good. So then this will be +1 to get x squared plus x. And that gives, yeah, you get minus x plus 2. I agree. Brilliant, yeah? So what is your, I'm just going to write out the full answer. I don't know if you can see. Can you see it? Yeah, you can. So you're going to get x plus 1. I'm going to show you that, or if you can't see it right now. So x plus 1 plus minus x plus 2 all over x plus 1. And that you can turn into partial fractions to get x plus 1 plus a over x plus b over x plus 1. All right? Again, I'm going to show you that properly, don't worry. Okay? So the x plus 1 is what you get by doing the division. Your x minus 2 over x plus xx plus 1 is your remainder. All right? And your remainder can be split up into partial fractions. And once you've done that, every single thing here can be integrated. All right? The x can be integrated, the 1 can be integrated. A over x will be an ln something. B over x plus 1 will be an ln something. All right? So do you see the logic of that? Type in the chat box if you don't understand. All right? See if I can move the camera so it's absolutely everything is visible. Right. There we go. All right? You don't understand. What do you not understand? Okay? Again, I'm glad you're telling me you don't understand, but you need to say what it is you do not understand. Because obviously it could be anything. It could be my handwriting. It could be whatever part. So you need to type down which part you don't understand and why you don't understand it. Where did you get lost in it? The part after you get the remainder. So what you do is you write the remainder on top of the denominator. Yeah? But that's just xx plus 1. So you can split it up as a partial fraction. A over x, b over x plus 1. That's all there is, right? And then you have to find a and b and integrate. Just like you did before. So basically, you've got this whole extra step to get this thing. And then it's almost like the last question you did, where it's minus x plus 2 over x plus 1. That can be just turned into partial fractions. All right? So that's the reason why. And that's what I'm doing. I mean, a plus 2, b minus 3. I don't know. So I haven't done it yet. I'll rub it out and have a go in a minute. Can everyone just check that, see if that's right? A equals 2, b is minus 3. Because I haven't got whiteboard space as it stands, because I'm leaving this up for those people that are, you know, still copying. Probably could just do the mental maths on it and go a, so that would give you what? Minus 3 plus 2. Yeah, that would make sense for a and b on the x. And then what would you have? Just a is minus 1. So a is going to be, yeah, it's a bit, yeah, I think so. You know, I think so. Just doing the sums in my head. But obviously you'd have to check that. We'll check that as soon as I get a minute. Once you've got those numbers, you can just straight up integrate. So obviously the integral of x is half x squared. The integral of 1 is x. The integral of a of x, integral of bx plus 1 are, you know. Remember to factorize the numbers out. Yeah, you got the same. Brilliant. Okay, cool. Is it okay to rub this out then? I'm going to give it another 15 seconds. on this board, then I'm going to rub it out, run it with the things that you've done it on. And that will be that. Okay, so let's rub that out just quickly. I'll rub out this bit because it follows through from here. So the integral of x plus 1 plus 2 over x minus 3x plus 1 would be a half x squared plus x. I'll move it so you can see all this, don't worry. Plus x plus 2 ln x minus 3 ln x plus 1 plus c. Now, so I'm just going to move the camera so you can see that much more comfortably. All right? You got A was 2. So did everyone else, I did. We agree. So fine, you got it right. Don't get put off. It's all good. All right? So those are the basic ideas you're going to need for the exercise we're doing. I'm going to add one more thing in a couple of minutes, or just a minute, actually. Okay, so let's move on. Right, let's move on. Sometimes when you do algebraic partial fractions like that, you get a term that goes, well, okay, it's a repeated root, and you end up doing your repeated root thing. Do you remember that from last time? And you've got 4x plus 1 over 10. And you think, well, okay, all the rest are just ln's. How do I deal with this? And the way is simple. Treat it as 4x plus 1 to the minus 2 and do inverse chain rule on that. Okay, so your guess would be x plus 1 to the minus 3. Chain rule it back down and see how wrong you were. So that's the only thing I really want to add to this. What you need to do for the next few minutes, at least, and this lesson is just 11G. And I mean, you can do a bit of 11H as well because there's nothing really much to 11H. But 11G is what I want you to finish by the end of this hour and a half. Page 312 and 313. Okay, and what's going to happen after that is that I'm going to come back for at 11 o'clock, and we're going to do the statistics. Anyone who's completely baffled before I start wandering off? Anyone who's totally, I mean, I can't get this, I don't understand what he's talking about. Because a lot of these, if you look at question 1, it's the same thing over and over again. Question 2 is the same thing over and over again. They get harder. To be fair, I want you to do all the practice, don't get it twisted. But I don't think there's too much, there's too much in there once you understand what I've taught here. I'm going to stay on for another minute to about 2 minutes in case anyone has any questions. The way I want you to, if you get struck, by the way, what I want you to do is message me. Yeah, 10:30, you need a break. Message me the question numbers that you can't do, and I might sketch out a solution in the second live stream, which is happening at 11 o'clock. So just a quick reminder, there will be a second live stream on statistics at 11 o'clock, but I'm happy to start that live stream with you kind of like taking on questions. And also remember that you need to be sending me work via Microsoft Teams, yeah? Pictures of your work. All right, that way I know you're working and you're learning, and then when the time comes, I can say, yep, they've learned this content, all right? So I'm hanging around here for another minute or so. So maybe a minute, couple of minutes if people, can we ask a question about another topic of the book? Depends what the topic is. If it's relevant, I'll do it. If it's not, I might do it later. I want you to stay focused on it's a lesson, right? In the same way you don't do random topics in class, you wouldn't do random topics here, but you can send me a question if you want to, all right? I don't want lessons to kind of lose their focus, but obviously I'm willing to listen to people within reason. And remember also, like, it is very much the case that if you ask me a question individually, that's fine. But, there are 8 people listening as well. People stop emailing, that'd be great. Okay, so that's me signing out then. I mean, are you serious? How many times have I said we're going to do 11G? Or, and it literally Rebut says, do we do all of 11G? I mean, common sense, right? It's 11G. Okay? Anyone's confused by that? Do we do all of 11G? Yes, we do. Good thing I saw that. I was even bloody wondering. Please listen the first time, or the second time, or the third time, or even the fifth time. All right? 11G it is. This is me signing out. I'll see you again at 11 o'clock. Any questions you're struggling with? Thank you. Like I said, I absolutely agree. Any questions you're particularly struggling with? Hold fire on them. Send me what they are. I'm waiting. I'm not going anywhere, Rebut. What's wrong? Okay. The suspense was killing me, Rebut. All right. As I said, it's not like I'm going anywhere particularly because I'm going to be back on here at 11 and we'll sort it out from there. Is that making sense? Any particular questions, send me the page number, or not the page number, the page number, send me the number of it. And if it's something that's really difficult, I'm happy to do it. If it's something really simple, I'll just tell you how to do it. Okay? I will see you all in about an hour and a half. Bye.